Hey guys, this is Arvind and you're watching Learn with Arvind. In this video, we'll be discussing on coordinate system and few widely used types of coordinate system. Let's start the video. Coordinate system is a system that uses one or more coordinates, which is nothing but values, to specify location in space. We use coordinate system to pinpoint a location in space. That's if we are given few values, few numericals, using that we will be pinpointing a location in space. The major concept involved in motion of a particle is its change in position coordinate with respect to time, which is nothing but it gives us velocity, and the change in velocity gives us acceleration. First, let's start with Cartesian coordinate system, which would be of the form P of x, y, z. Let's mark a point P which is in the XYZ axis. Let's connect the origin and P. It specifies the location with numerical values. Cartesian coordinate system specifies the location using numerical values, which is nothing but the distance from their respective axis. For instance, take this point P of x, y, z, which means that this point P is at a distance of x in its x-axis, and it is at a distance of y in its y-axis and z in the z-axis from its origin. So if we extend this x, y and z, mark this as y, this at a distance of y, and if we extend this in the xy plane, which is nothing but we are going to project this P on xy plane. It is at a distance of z from the z-axis. Not from the z-axis, it is at a distance of z from its origin along the z-axis. Now you could clearly see that this point P is at a distance of x along its x-axis and y along its y-axis and z along its z-axis. For example, take if it is at a P of 2, 3, 4, then which means that it would be at a distance of 2 along x and 3 along y and 4, z. Now let's move on to polar coordinates. This polar coordinates, first before starting that, it is two-dimensional. It is two-dimensional. This polar coordinates will be of the form P of r, theta. Let's mark a point P of, this point P is at a distance of r, which is distance between origin and that point. This is the first coordinate, and it makes an angle theta with the reference axis x, which is the same coordinate. So if you are given just two coordinates, the distance and the angle theta, then we could specify the location. This is what polar coordinates is. Consider for having another point P2, and let the distance be r2. Let's make this r1 and theta 1. The distance be r2, which makes an angle theta 2. You may think this theta 2 may look like this, but it won't come along the left side. The reason is theta will always be in the anti-clockwise direction from the reference axis. That's how we should draw the angle theta, and it should not be the shortest angle. It is not the shortest angle. It is the angle from the reference axis x along the anti-clockwise. Not x-axis, but usually it's x-axis. Distance from reference point is r. This r is nothing but it is a radius. If we extend this, goes on a round trip, then you could see it's nothing but a circle. That's what polar coordinates is. You could see that could be converted in terms of Cartesian coordinate system. This P of r, theta can be converted into P of x, y, z. Now if you are having a polar coordinate, this can be converted in terms of Cartesian coordinate system. To convert this, that's a relationship. The relationship between polar and Cartesian coordinates is given by, which is nothing but, if we know r comma theta, that's if we know the distance r and theta, then we could change this in terms of x and y. That's x is given by r cos theta and y is given by r sin theta. This r is the distance and theta is the angle. R is equal to root of x square plus y square and theta is equal to tan inverse of y by x. If r and theta are known, then we could convert this in terms of p of x comma y. Z is missing. The reason is this is two-dimensional and this is what cylindrical polar coordinates is. It is a 3D version of polar coordinate system. You could see clearly, mark a point P. This is nothing but you are having x, y and z axis whose origin is placed on the center of the circle of the cylinder. You are considering yourself, your axis is placed inside a cylinder. This is what cylindrical polar coordinate system is. First we will be looking at the first coordinates, which is rho. This rho is nothing but it is the projection of P along the xy plane. This rho is nothing but it's projection of P. We are projecting P along the xy plane. So it is the distance, it is the length of the projection of P on the xy plane. And theta is the angle between x and rho. Theta is the angle between rho and reference axis. Most probably it's x axis in most cases. And the next coordinate is z. Distance z is the perpendicular distance from the plane xy. Now this could be related with Cartesian coordinate system too. That's we are converting cylindrical polar coordinate system into Cartesian polar coordinates. The relationship between cylindrical polar coordinates and Cartesian coordinates is given by x is equal to rho cos theta, y is equal to rho sin theta, z is equal to z. This rho is the length of the projection and theta is the angle. Rho is given by root of x square plus y square and theta is tan inverse of y by x and the another formula is sin inverse of y by x. You could see this is just the extended version of polar coordinates. Now let's move on to spherical polar coordinates. Consider you are having a sphere whose center is nothing but the origin of the x, y and z axis. This is what a spherical polar coordinates is. If you are having a point P on the sphere which is at a distance of r from the center O, it is also the 3D version of polar coordinates. Not only cylindrical polar coordinates, spherical polar coordinates is also the 3D version of polar coordinates. R is the distance between origin and the point P, which is nothing but the radius of the sphere. This theta is the angle between, we are projecting P along the xy axis. And the angle between this projection and reference axis x, this is what we mean by theta. Now the third coordinate is phi, which is nothing but it is the angle between z and OP. This angle extends from z. Don't forget that it's not between OP and z. This angle should extend from z. Now there are few conditions. That's r should be greater than or equal to 0. Since r is a distance, so it cannot be in negative terms, and theta should lie between 0 to pi. The value of theta should range between 0 to pi. And the third coordinate phi, it should range between 0 to 2 pi. Now let's make this as a sphere. Since it looked like a circle, I'm making this like a sphere. Okay, this coordinate can also be related with Cartesian coordinate. The relationship between spherical polar coordinate and Cartesian coordinate system is given by x is equal to r sin theta cos phi, y is equal to r sin theta sin phi. This r is the distance between O and P, and theta is the angle between projection and reference axis, and phi is the angle between Z and OP. R is given by root of x square plus y square plus z square. Theta is equal to tan inverse of root x square plus y square divided by z, and phi is given by tan inverse of y by x. See you in the next video, guys.